I want to introduce a basic rule of thumb comparison chart between transformer technologies. I want to compare a standard delta Y transformer to a K13 type transformer to the HMT. First column we'll look at is approximate cost. If we consider that a standard delta Y transformer cost 1x, the K13, because of its oversized nature, will typically be much higher in cost, 1.5 to 2 times that, with the HMT cost being 1.5 to 4 times the base cost of the delta Y. This occurs because of the additional labor needed to custom wind the HMT. The smaller size HMT will be on the larger scale, the 4X, whereas a larger size HMT, around 112.5 to 150 kVA, will be comparable in cost to the K-rated transformer. Now, of course, initial cost is only one aspect we should look at. What is of more importance, I think, is the second column here listing energy usage. Say the standard delta Y has 100 units of loss in its conversion process. The K-rated transformer, when feeding a same type of load, will have 130 units of loss, 30% more loss because of the combination of being a much larger, oversized transformer and still having the same delta Y configuration. Whereas the HMT will only incur 40 units of loss, which is 250% less because of the mitigation and harmonics in the primary of the transformer and on the system. And of course, the last column represents what I consider to be icing on the cake. The standard delta Y transformer was never designed to have power quality attributes. The K-rated transformer is only oversized and bulked up to withstand the heating effects of harmonics, whereas the HMT corrects the root issue. Yes, the initial cost of an HMT is greater than the other transformers. However, the energy savings you receive over the lifetime of the transformer easily pays back for itself. Using an HMT has the same mentality as using a compact fluorescent lamp. Sure, an incandescent light bulb is going to be cheaper than a compact fluorescent. When you look at the reduced labor involved with the compact fluorescent because of the much longer life than it will have, and the fact that you're getting much better light with the reduced watt consumption, makes it a win-win scenario. It's this long-term energy savings I would like to spend some time on. Eaton has gone one step further to show customers the real-world performance of the HMT inside of their buildings. In the fall of 2006, Eaton conducted HMT transformer performance with linear and nonlinear load. This transformer testing occurred at the Eaton Power Quality Experience Lab in Warrendale, Pennsylvania. This lab is specially equipped to handle this type of testing because it has both linear and nonlinear load. It's very easy to see why many manufacturers will only want to test with linear load, as the linear load bank shown here cost around $7,000 to purchase. This represents about 70 kilowatt of load. To create nonlinear load banks for testing, Eaton has custom created computer power supply racks to be the source for nonlinear load. Each rack, which cost around $15,000 to build, consumes about 35 to 40 kVA. The testing facility currently has 4 of these racks to produce a load on transformers around 150 kVA.